countries. I'm sure that there are even some of you on the line now that I've spoken to before, maybe worked on a case with you, but I wanted to reach out to you all and say welcome. Thank you for taking your time to be here today. I hope that you find the webinar to be a valuable tool to help you process cases involving gunshot residue. And on a personal note, I hope you're all feeling well and healthy and staying very safe today. So today we're going to focus on specifically the collection of gunshot residue samples. We're going to talk about different types of sampling media, which is just a fancy way of saying the different tests that are available to collect gunshot residue samples. We're going to talk about considerations when collecting and give you some demonstrations on how to collect samples from hands, from clothing, and from some other surfaces like vehicles. I think in my time of analyzing and collecting gunshot residue samples, I've collected from some pretty interesting samples, anywhere from pianos and door jambs to clothing and yes, even underwear. So lots of fun things I've collected from over the years. We're also going to touch on swabs, like the Q-tip type swabs. And we're also going to talk about XCAT samplers and also a few other considerations when collecting gunshot residue samples. So it's very important to know and understand the proper techniques and also the mitigating circumstances surrounding the collection of GSR. If you do the collection properly, it makes testifying for us and for you so much easier. So we really want to start at the basic, at the ground foundational level for collection. As Dennis said, we will have a question and answer session at the end of the webinar. But if you do have a question during the discussion, please feel free to type it in that question chat feature that Dennis mentioned, and we'll get to as many questions as we can. Okay, so let's go into a little bit of background first. The ever-present question in my life: what is gunshot residue? I'm pretty sure that I've answered this question more than any other question in my life, with the exception of probably, hey mom, what are we having for dinner? But this question I'm pretty familiar with answering. So gunshot residue is really an umbrella term that includes all of the particulate and all of the material that comes out of a firearm whenever it's discharged. You can see all of these vapors coming out in this fabulous picture we have there. So there is burned and unburned and partially burned propellant, or what you might know as gunpowder, that exits during a discharge. Firearms examiners, not trace evidence examiners, but firearms examiners use this type of GSR or gunshot residue to conduct distance determination testing to determine how far away a potential shooter was from a target. Now, when I, as a trace evidence analyst, am analyzing gunshot residue, I am not looking specifically for that gunpowder or propellant. I am looking for particulate or residue that originated from the primer. So what you're seeing here in this particular picture are a bunch of cartridges lined up end to end. I'm sure you're familiar with this. This is center fire ammunition, which means the center of those cartridges, the center of that bullseye, if you will, is called the primer cap. In that primer cap, there's something called the primer mixture or the primer paste. The primer paste is made up of elements, specifically and typically a combination of compounds known as lead stiffnate, antimony sulfide, and barium nitrate. Now, I don't want to get too technical into any of this, but suffice to say, it's the combination of 3 of those inorganic elements, lead, antimony, and barium, that create the primer gunshot residue that I'm looking for when I'm analyzing a sample. So basically what happens is the trigger is pulled, something called the firing pin strikes the back of that cartridge, and you can see the impression there on those pictures. The very center of that bullseye is where the firing pin would have struck those cartridges. That firing pin striking the cartridge activates the primer, which ignites the gunpowder, and you get this buildup of heat and pressure inside the cartridge. That reaction is so intense that the bullet is forced down the barrel of the gun and toward its target. The heat and pressure also cause the lead, antimony, and barium in the primer to vaporize, and the vapors escape the firearm from any area of the weapon that isn't gas tight. So moving back one slide, just so you can see those gaseous vapors that are escaping the firearm. So those vapors are going to escape the muzzle, the breech area, the ejection port, all of the areas of the firearm that aren't gas tight. And they form that cloud of smoke, that vaporous cloud of smoke around the firearm, and we refer to that as the plume. Now, as that plume cools, that lead and antimony and barium in that plume condense together and join together, creating particles of primer gunshot residue. So think about it as if you had a cake, if you were making a cake. So you've got all your different ingredients. You've got your sugar, you've got your flour, you've got your water, you've got your eggs, all the stuff that you need to make a cake. And you mix that all together and you kind of get this lumpy batter. In the plume, we've got our lead, antimony, and barium mixed together, creating one particle type, a primer gunshot residue particle, a 3-component primer gunshot residue particle. And it's these specific particles that are characteristic of gunshot residue and that we call highly specific to the discharge of a firearm. These particles land on the hands and the clothing and the surrounding area of a shooter. These particles, however, are incredibly small. They can't be seen with the naked eye. They are microns wide. And to give you an idea of how small a micron is, here's a quick picture of a one piece of human hair, the diameter of one piece of human hair next to a particular demonstration of a gunshot residue particle where that little guy there. So if you think of your typical meter stick, right? On one side of it, you have inches. On the other side of it, you have centimeters, okay? If you divide your centimeter up by 10, that's a millimeter, okay? So every little centimeter has 10 millimeters in it. If you divide 1 millimeter by 1,000, that's a micron or a micrometer. Okay, so these particles are very, very, very small, which is why you need a high-powered instrument like an SEM or a scanning electron microscope in order to analyze gunshot residue. Okay, so now that you have a bit of a background on primer gunshot residue, and I'm sure a lot of you already knew that, but just stick with me. Let's discuss why gunshot residue is actually really valuable evidence. I'm sure you've heard here or there about a lab that is no longer analyzing gunshot residue, or perhaps your state lab stopped accepting samples, or even you could have even potentially heard, oh, we don't collect gunshot residue because it's not reliable evidence. Why should we do it? So it is true, I will concede that there are certain labs not analyzing it anymore. And there are many reasons why labs aren't analyzing it. And every lab's reasoning could be different. Some may be because of backlogs or lack of cases. It could be too expensive to keep up the instrumentation. There could be a lack of an analyst or an expert that is necessary to actually analyze the samples. But the reason is absolutely most positively not because it's not a reliable form of testing or that is not reliable science. It's true, finding gunshot residue on an individual doesn't mean that he or she definitely shot a firearm. If you find gunshot residue on an individual's hands, I could never tell you, this is the person who definitely did it. This is the person who shot the firearm. And we've never ever claimed to be able to do that. However, if somebody is positive for gunshot residue, it does mean that they could have shot a firearm, which is evidence that a jury deserves to hear and evidence that a jury deserves to weigh out during a trial. During a trial, a GSR expert has to kind of play the role of a teacher. They teach the jury the background of GSR as an evidentiary item, as well as the different nuances and circumstances that surround the results and the collection and the analysis of the samples. So GSR can really be a very important piece to the investigative puzzle. A positive finding is probably the most probative or the most helpful in cases where a person says that he or she wasn't near a firearm when it discharges. So if someone says, I wasn't around the firearm when it discharged, I haven't been around it, I've never been around a firearm, and then they test positive, then somebody's got some explaining to do, because that is definitely an instance where it is probative evidence. And the main reason for that is that gunshot residue is not very common in the average person's environment. But a person who fires a gun will most likely have residue on them for a certain amount of time. And there's numerous population studies that support this fact. So Joe Schmo walking down the street, I wouldn't expect that particular person to have gunshot residue on their hands or their clothing. So somebody having gunshot residue on them is important to note, especially for a trier of fact. Kind of conversely to a positive finding, a negative finding doesn't necessarily mean that a person was not in the vicinity of a firearm. It only indicates that there was no residue found on this item. So a negative finding isn't necessarily a bad thing. Also, it's important to note that over time, particles can be lost. You can and you do lose particles from your hands or your clothing if you had particles on you to begin with. And while a transfer of particles from one item to another item, for example, from a police officer to a subject, is possible, the likelihood of that transfer in most cases remains small. Okay, so while transfers can happen, and while they are possible, the likelihood, again, is small. GSR evidence is, with most trace evidence, not meant to be a conclusive type of evidence. It's not your smoking gun. Haha, see what I did there? It's supportive and it's circumstantial evidence, okay? So these particles are highly specific to the discharge of a firearm. Scientists are also continuing to search for particles that look like gunshot residue particles, but are not gunshot residue particles. And in their continual search, they're only strengthening the fact that these particles are highly specific to the discharge of a firearm. Okay, so looking for particles that look like gunshot residue but aren't, that's something called a false positive. So scientists are continuing to look for false positives and not finding very many. And then on top of all of this other valuable background information on gunshot residue, on top of everything else, the technology that is used to analyze gunshot residue has been around since the 1970s. It's scientifically sound technology and it's a confirmative technique. So overall, gunshot residue analysis is an incredibly valuable tool. So for a jury to understand the significance of gunshot residue findings, that expert has to review all these aspects of gunshot residue. And that starts from the very beginning, from the collection. If the collection procedure is done properly and effectively, it makes testifying for you and for me so much easier. The very best method, the standard method for collecting gunshot residue samples is to use a scanning electron microscopy kit. These kits contain adhesive lifters. Those are these little cylinders that you see right here. I refer to them as stubs. Sometimes you hear them called dabs or dabbers or pin mounts even. But they're all the same thing. They're these little pieces of sampling media right there. Multiple companies sell these kits, including RJ Lee Group. RJ Lee Group does sell a kit as well. Tritech Forensics actually manufactures our kits for us, but manufacturers like Tritech, Searchy, Arrowhead Forensics, Evident, as well as some other manufacturers that aren't particularly on this slide, Kinderprint, Lin PV, etc. There's lots of different manufacturers that manufacture gunshot residue hand kits, specifically SEM kits. And RJ Lee Group will analyze all of these kits. We don't discriminate against any kit. It doesn't have to be an RJ Lee Group kit for us to analyze it. So just something to keep in mind there. all kits are typically going to have a pair of gloves in them for collection, an instruction sheet for how to collect, and a case documentation sheet. An evidentiary seal will typically be in the kit as well. Now, when it comes to the actual dabbers themselves, that's where things differ a bit. You can have kits that have 2 stubs, a right hand and a left hand stub. Some kits might have 3 stubs, a right hand, a left hand, a face. Some kits have 4 stubs, right back of the hand, the right palm of the hand, the left back of the hand, the left palm of the hand, etc. So you get the idea that we've got some different kits out there. So this is an excellent picture right here of the stubs that are in an RJ Lee group kit. So I want to just point out that our particular kit also has a control, and a lot of kits do have a control. Now, the control sample itself can be used in different ways. It can be used specifically as an environmental control to test the environment in which you are actually doing the collection to make sure that there's no contamination occurring in your environment. It can also be used as just a kit control or a sampler control to show that there was absolutely no contamination on the kit itself before the collection was done. So it's up to you and your individual agency to determine and to choose how to use the control if your kit has one. So while our kit has 2 stubs per hand, meaning we have a left palm and a left back, 2 stubs for the left hand, a right palm and a right back, 2 stubs for the right hand, you can most certainly use just 1 stub to cover the entire hand. So kits that are just have 2 stubs in it, a right hand and a left hand, are totally fine to use. So while most kits do separate between hands, right hand and left hand, that really holds no specific significance to me as the analyst. It's just separated to get your maximum sampling power, just to get as much energy as you can, as much particulate as you can off of your particular, from your particular samples that you're collecting from. So if there happen to be a ton of particles on the right hand samples and not very many on the left, that doesn't mean that your subject was right-handed. It just means there's more particles on the right hand than on the left hand. And the reason we can't say that this means the person was right-handed and shot with the right hand is because we don't know the activity of the hands of the individual between the time of the shooting and the time of collection. So both hands were likely in the vicinity of that primer residue during the discharge. And it's also possible that there was more gunshot residue on one hand and it got transferred to the other. So right hand versus left hand really has not a lot of significance to us, with the exception of just getting as much particulate off of the hands as possible. So here's a little bit of a close-up picture of a stub. As you can see, there's a plastic base which holds an aluminum pin mount. The pin mount will have a double-sided adhesive material. This particular picture shows black adhesive material because it is carbon-based. That material is very sticky, and that is the part that will actually come into contact with the area that is being sampled. Finally, there's a plastic cap over here. It has the label of right back on it, and that goes on top of the base to create an airtight seal on the samples whenever it's closed. Just a few considerations to think about whenever you are getting ready to collect samples. You want to collect samples as soon as possible after apprehending a subject, and preferably before transporting him or her to a police station. Always wear gloves when collecting from a subject to prevent contamination. This is a very important step. It will no doubt come up during testimony, and it will help a lot if you for testimony and whenever we're discussing potential contamination issues. It will help us a lot if we can say that the collecting individual had gloves on, the proper PPE. While it's possible for gunshot residue to be transferred from a police officer or to a subject, there are, if while it's possible for a gunshot residue to be transferred from a police officer to a subject, studies have shown that very few police officers have particles on their hands, basically because they clean their hands more often than they touch their weapons. So you're washing your hands more often than you're actually having the potential of getting primer residue on you. Now, it still is a possibility, but having that PPE, those latex gloves on is really going to give you that extra layer of protection. If you have recently fired your gun, you should not be the person collecting samples. There should be somebody else that should come to collect them. Any possibility you can, and anything you can do to eliminate any potential risk of contamination, we want you to try to do. Prior to collecting samples, you also want to avoid contact with the subject as well. So specifically the subject's hands. If possible, collect samples prior to transporting the subject in your vehicle. If you have to transport them in your vehicle, we always recommend to bag your hands, to bag the hands of the subject before putting them in the vehicle and transporting them. It is possible to get secondary transfer of particles from the back of a police car, but the potential is low, especially if the hands are bagged. And something else that you can do to minimize that risk is to do a contamination check on the back of your vehicle. Actually take one of our gunshot residue samples and sample from the back of your police car and see if there are particles back there. So being able to do a test like that can help to minimize the risk of contamination and can also help with testimony considerations as well. And finally, I hope this goes without saying, but you should never expose your gunshot residue samples to the firearms section of your agency or laboratory. Obviously, that would not be very good. Okay, so we have a small demonstration here of how to collect from hand samples. I'm going to apologize ahead of time for the little bit of shakiness. We did our best with our little evidentiary camera, but I wanted to point out first and foremost that this is one of RJ Lee Group's kits. Here you can see there is a paper with the instructions on it. There is a case information paper. Here's our 5 stubs, our gloves, and our little evidentiary seal right there. So I'm going to go ahead and start this video, and I will probably stop it periodically to make some comments here or there. Okay. There's our kit. Ta-da! This is the accompanying instruction sheet. That's the accompanying case information sheet. I'm going to stop here just to let you know that that case information sheet is informative and helpful for us, but if you do not fill it out, that is quite okay. We can certainly accept something else on your agency's letterhead, letting us know what your case number is and so on and so forth. 5 stubs, the right back, the right palm, the left back, the left palm, and the control. Obviously, these stubs correspond to the particular areas of the hand. The right back sample will go with the right back of the hand. The right palm sample will go with the right palm of the hand, etc. Of course, we also have the control. If you'll notice what I'm doing here, as I was opening the stub, I'm shaking it back and forth. So you don't want to squeeze too hard on the vial and crack it. You simply want to hold the vial in your hand and rock back and forth to pull that cap off of that vial. So I'm doing that here for the control. What I've done here is just put the stub onto the area where I am going to be collecting samples. So in this particular instance, I would be using this stub as an environmental control. You can simply have it sit out on the table while you are collecting samples from the individual of interest. Another thing you can do is also sample from the table or the paper or the area in which samples are being collected. But this is just to give you an idea of how an environmental control can be used. And I'm going to go ahead and put the cap back on there. As I mentioned before, you can also use the control as just a control for the kit itself. So you don't even have to open the lid to the control at all. You can leave it sealed, airtight, and it will let us know that the kit itself had no primer residue on it to begin with. So I went ahead and put the lid back on there. Okay, now I'm putting on my PPE, my latex gloves that were included in the kit. Well done, Allison. This is the right back stub. I have to pause here and just give a little shout out to my person who played my subject to collect here. This is Mr. Jim Knopp. He was my sampling subject there. So thanks a lot, Jim. Okay, so if you notice what I did, I pointed out the area between the thumb and the forefinger. This area is called the webbing of the hand, and this area you typically want to sample from first. This is the area that is kind of like the most probative area for getting primer residue from. So I take the cap off, and then I get to work. Okay, so what I'm doing here, it's a very technical term. We call it dabbing. We're basically just putting that adhesive material in contact with the area of interest. In this case, it's the right hand back. I'm starting with the area between the thumb and the forefinger, and then from there, I go back and forth over the entire hand, back and forth. After I collect vertically, I will then go over horizontally. So basically, I'm creating a grid over top of the area of interest. So I'm going back and forth vertically and then back and forth horizontally, covering the entire area. Make sure you get the fingers, make sure you get in between the fingers. Now we're moving on to the right palm, wiggling back and forth, and then continuing to dab. You want to go all the way from the wrist all the way down to the tips of the fingers. So that's my little motion to say, continue doing this all the way down the hand. And then we're going to go back over that, creating that grid-like motion. And of course, once you have completed the right palm sample, you move on to the left hand. Now, if you had a kit that just had two stubs, a right hand and a right back, you still start with the area between the thumb and the forefinger, that webbing area, and then you just continue to cover the entire area of the hand. I do want to point out that you don't really need to apply a ton of pressure whenever you are dabbing. You don't have to smash it into the individual or into the item that you are sampling from. So it's not necessary to push incredibly hard. These samplers are very adhesive, and the particulate that is there will be extracted simply by a light, mild pressure dab. Okay. So some labs have what we call cutoff times, meaning that they will not analyze samples if they were collected too long after the suspected discharge. So some labs won't analyze samples if they were collected more than 6 or 8 hours after the discharge. There's various reasons for this, and research has indeed indicated that after about 4 or 5 hours after a discharge, it's less likely to find gunshot residue due to the activity of the shooter, running, moving, washing your hands, etc. That's not to say that you can't find gunshot residue after 4 to 5 hours, but it is less likely. So there are labs that implement that cutoff time because of that information. RJ Lee Group does not use a cutoff time. We feel that if you feel it's probative to have the samples analyzed, then we'll analyze them for you. But we do want you to be aware that particles are lost over time. If it has been a longer time since the discharge, you do have the option of collecting samples from the subject's clothing or another surface that the subject may have been around. I've collected samples from watches, from purses, from shoes, from wallets, different things that the subject may have touched or been around. So studies have shown that gunshot residue on clothing can and will last considerably longer than on hands. It does depend on lots of factors like the activity of the shooter and the type of the fabric, etc. But studies have shown that they do last longer. Now, where you sample from on an article of clothing depends on a lot of different things, specifically where the person was believed to have been carrying a gun or concealing a gun. Typically, we're going to analyze the front areas of a garment unless we're instructed to do otherwise. Sometimes we're instructed to sample from a pocket or a waistband, typical areas that a gun can be concealed. But you really can sample anywhere. Now, whenever you are collecting from clothing, you want to be sure to avoid areas of heavy debris or biological material, as gunshot residue there will likely be masked by that material anyway. So if there's an area that's particularly bloody or has a lot of debris, dirt or grass, anything like that, you kind of want to sample around that. The technique that we use to sample from clothing is the exact same technique that we use to sample from hands. And you most certainly do have the option of sending RJ Lee Group an entire garment to sample from. We can do the sampling of that garment for you. And the one benefit to having us do that is that we can offer a contamination-free environment in order to sample that item for you. So that's just one less thing you'd have to worry about when testifying. So this is an example of what a fabric or a surface kit looks like. It's slightly different from a hand kit, and there's no informational sheet included on there. And there's actually no labels on the stubs. The package itself indicates, if you look right here, it indicates where you can sample from. It's kind of hard to see, but the numbers here are 1, 2, 3, 4, 5, 6. So you could label a stub as 1 and sample from the right sleeve, as 2 and sample from the right side. But just because this is an example of what to do does not mean that you have to follow it. That's why the stubs are blank. You're welcome to label it any way that you like. You can use those stubs in any way that you like. So there's one small difference with the stubs from a fabric kit. These stubs don't have that black carbon adhesive material. Instead, they have a clear adhesive material. It's just a little stickier than the carbon and can really help to get into the weave of the fabric. So if necessary, you can use a carbon stub on clothes, or you can use a fabric stub on hands. So here's a little movie of our fabric stub collection. Again, please excuse any shakiness. There's a close-up of our 1, 2, 3, 4, 5, 6 possibilities. Here are the 6 stubs that are blank. So I'm just using a Sharpie marker here, and I'm going to write right on that stub. What I'm writing is sweater right sleeve, because I'm going to do a particle extraction of the sweater. What I'm doing now is grabbing a piece of Scotch tape to put over top of the writing. This just helps to protect the writing to make sure that it doesn't come off. I have my garment laying out on the table, and I'm going to be collecting from the right sleeve of the garment. Right now, I'm also getting a blank stub that I'm going to use as what we refer to as our PE control, or our particle extraction control. So it's going to sit out open in the room while I am particle extracting. And then I just go ahead and wiggle the lid off of that sample, and I'll get to work. You can see how that adhesive material on the stub is sticking to the garment, okay? You want to try to touch the garment as little as possible, okay? And just like we did on the hands, you're going to go back and forth over the area of interest. So with the right sleeve, I'm going to start at the bottom of the cuff and go all the way up to the top of the sleeve. I then go back over it in a vertical motion, again, creating the grid pattern, collecting as many particles as we can from that garment. Again, you don't have to push very hard. You can see that it's still very sticky. And I'm going to do an example right here. I just pushed down to show you just how sticky that sample actually is. So you don't have to push very hard. And again, you want to make sure to avoid any areas of debris or biological material like blood. Okay, so then you just continue on with the rest of the garment. Okay, so these samplers can also be used on other surfaces like a car. You're going to use the exact same collection technique on the car. For example, here's an example of collecting from a steering wheel. I decided to basically divide this steering wheel in half so I didn't lose my place. So I'm starting at 12 o'clock and moving all the way toward 6 o'clock and back, just getting as much area as possible. And then I will do the other half of the steering wheel. So this is just a nice example to let you know that there are lots of different surfaces and areas that you can collect from. Again, ensure that you're wearing the proper personal protective equipment whenever you do that. So just a quick word about swabs. Before gunshot residue collection was done using SEM stubs, swab kits were used that look kind of like this. Some of you might remember them, and some of you might even still have them. Please say no. This is an outdated form of testing. More importantly, it's a bulk analysis and not a confirmatory analysis. It uses a technique called ICP-MS, inductively coupled plasma mass spectrometry. It basically can tell you, if you collect with a swab, it basically can tell you there's this much lead there, there's this much barium there, there's this much antimony there. That could be indicative of gunshot residue, but what it doesn't do is show you those three elements combined in one particle. And that's what we need to say that something is highly specific to the discharge of a firearm. So we do not recommend these kits at all. You'll be hard pressed to find a lab that will still analyze them. So if you happen to have an old atomic absorption, an old AA kit, what RJ Lee Group can do is we'll actually take those swabs and kind of tease them apart and do a particle extraction on the swab itself. So we're actually doing the SEM analysis on the Q-tip. And for anybody out there that happens to still have these atomic absorption kits, if you want to send them to us at RJ Lee Group, the unused kit, we'll send you back SEM kits in their place. Okay, more recently I've gotten questions about this particular device. This is known as the XCAT, and it's so tempting because it says right there, you get instant results as to whether or not someone has GSR in their hands. So my answer as to whether or not I think this is good, if I would recommend XCATs, my bottom line answer is I recommend GSR SEM stubs over this device. This is a presumptive test. Basically, what you do, if you look at that little picture up there, it has you pull back an adhesive material. Just kind of like the adhesive on the stub. You then dab that material over the hand, or the area of interest. After you do that, you use that little white pad right here and you swipe it over the exact same area. You then put that adhesive material in contact with that white pad and then put this cartridge in this device. You hit a button and you get a reading as to whether or not it's positive or negative. The problem is this is a test for the presence of lead. There's lead in lots of different things aside from gunshot residue. It doesn't tell you whether or not primer residue is there. It can tell you whether or not lead is there. So if you get a positive result, you still have to send the cartridge to us to look at it for a confirmatory SEM test. The problem is once we pull that adhesive off of that pad, half of that pad comes with the adhesive and we lose the area that we were going to analyze to begin with. So my bottom line answer is it's much better for you just to do an SEM kit in the beginning and not go through the whole presumptive testing of it. Okay. Okay, just a few other sampling considerations. As an investigator, a technician, or simply a person who might be the person collecting GSR samples, there are certainly things that you should consider when you're contemplating what items would be the most probative items to test for GSR. Remember that the number of particles that are collected and the amount of particulate loss vary widely from case to case with the activity of the subject. As I've mentioned, particles can be removed with activity, and depending on the conditions, particles may be removed from a shooter's hands within 4 or 5 hours after a shooting event. So could clothing be a better option for your case? Particles can also transfer from a surface or a person to another individual, and tests show that people standing within a few feet to the side of a shooter may have GSR on them, whereas those standing 10 or more feet will not. This is just information to keep in mind. And finally, it's totally common for different labs to have different case acceptance criteria. For example, your state lab might not accept samples from victims, or your local lab might not analyze clothing samples. Each lab has to assess the needs of its community and decide what works best for them. The biggest example of this is the FBI lab no longer takes GSR cases. Simply, it's not because it doesn't believe in the science, and it will still to this day stand by every test it did, but it decided to use its resources to serve its particular community, which with the most important thing at that particular time, fighting terrorism. So the FBI does not take gunshot residue cases anymore, but they do send them out to agencies like RJ Lee Group to analyze for them. So overall, the choices that you make and the way you conduct your collection is very important. It makes your testimony and our testimony so much easier when we can get in there and say, yes, the correct method was used to collect these samples. Yes, it appears all the necessary precautions were taken. Nothing about these samples indicated that they were collected improperly. You are the first step to ensuring the most accurate and probative results. And if you ever have any questions at all, you can always call us and we can walk you through the steps. And with that, I just wanted to thank you so much for your time.
Thank you, Allison. Thank you so much. Before we get to questions, here's a reminder that when we're done with the questions, a survey is going to pop up. So we'd love to have just a minute of your time to answer those questions, help us offer better content in the future, and let us know how you're doing. If you answer those 8 questions, we'll give you $100 off and analysis for your feedback. So here's our first question for Allison. What can you do if you don't have a GSR kit on hand?
Okay, that's a great question. If you don't have a gunshot residue kit on hand, well, first and foremost, I would recommend collecting the clothing if possible. If there's clothing to be collected, you can put that clothing in a paper evidence bag, and we can get you a kit and you can collect samples later on. If clothing is not an option, then something that you can do in a pinch, I would recommend even a roll, like a tiny donut of Scotch tape, even over a swab. You probably have a better chance of getting particulate from that Scotch tape instead of the swab. But clothing first, Scotch tape last, and if it's possible for us to get you a kit instead of having to use that Scotch tape, then that is also something I would recommend.
Thank you. Is RJ Lee Group accredited for GSR? That's just all it says. Does that make sense?
Yeah, yes. RJ Lee Group is an accredited laboratory. We are accredited by ANAB, and we are accredited for primer gunshot residue analysis as well as distance determination.
Okay. Here's one. If you are sampling from a vehicle, what areas should you sample from?
Gotcha. That's another great question. Really, it's up to you where to sample from. Areas, you want to think about the areas that are going to be most probative to your particular incident or your particular case. So if you think that the person driving the vehicle is the one who discharged the vehicle, then the steering wheel, the headliner, the inner door panel are all good options. If you think it's somebody in the back seat that discharged a firearm, then the inner door panels of the back seat or the seat itself or the headliner above the back seat are all good options as well. If you think that somebody discharged a firearm and then got into a car, think about areas where they would touch. Again, the steering wheel, the door handles, perhaps the radio or air conditioning unit. But those are all potential areas that you can collect from. It's really up to you.
Okay, thank you. Here's one that's maybe a little more technical. It says, if you are using a kit with one dabber per hand, does the dabber run out of stick, or have you found one dabber is as accurate as two per hand? Does that make sense?
Yes, it does make sense, and that's a great question. In my experience, no, the dabber has not run out of stick. What's most important is that you get the most probative area first. So as long as you sample from in between the thumb and the forefinger first, that's the area where you're going to get potentially the highest concentration of particles. And it might not seem as if the dabber is as sticky, but believe it or not, it actually is. You just can't see it. These particles are so small that not only are they using the adhesive property of the material, but they're also kind of using the electrostatic forces to pull the particulate onto the stick as well. So 2 stubs, 1 for each hand, is totally fine.
Okay. What would be the proper procedure for collecting a GSR, then DNA swab from a steering wheel, for example? And would it be a stub for GSR and then swab for touch DNA?
That's a great question. We get lots of questions about the chicken or the egg. Do we want to analyze do we want to collect GSR first or DNA first? And to be honest with you, a trace evidence analyst is going to tell you collect for GSR first, and a DNA analyst is going to say collect for DNA first. Let me jump back and take the latter part of the question first. In terms of what collection media should you use to collect for DNA, it's most common for me to have seen swabs to be collected for DNA, but I am not a DNA expert. So that is a question that really should be posed to a forensic biologist or a DNA expert as to what is the best sampling media for touch DNA. But in terms of what you should collect first, I, of course, want to say primer gunshot residue, but if it is a steering wheel, for example, I would probably collect for touch DNA first, just because that evidence is going to be more important if you can get a profile than potential primer residue that could be on there. So I would collect for touch DNA first and then primer gunshot residue. That touch DNA is more sensitive, I should say. Now, however, if you are looking at a garment and you're going to collect DNA from a garment like a sweater, there's particular areas that are going to be more probative on the garment for DNA than for primer gunshot residue. So for example, if you have a garment that has biological or suspected biological material, you can still collect for a gunshot residue first, because I can just avoid the areas of that suspected biological material, and then it can go on to DNA. However, if DNA is collected first, that's also fine. We can still collect primer residue after DNA has been collected. I hope that helps.
Okay, thank you. Everyone notice forensics at rjleaguegroup.com is down there. We have one, can GSR collected be matched to the firearm it came from or to the casing/bullet recovered?
Oh, that's another great question. Oh my gosh, you guys are full of them. The short answer is, unfortunately, no, it cannot. Primer residue, lead, antimony, and barium are those three major components that are going to be in the majority of ammunition that we see. So most often we're looking for lead, antimony, and barium, and we cannot track that back to a particular ammunition or, unfortunately, even a particular firearm. Now, there are cases in which we see special elements. For example, if we see tin mixed in there with lead, barium, and antimony, then that sometimes indicates a certain type of ammunition over another. But unfortunately, we can't be specific about what type of ammunition that is.
Okay, I'm going to do one more here because we went over on time a little bit. But just a reminder to everyone, as soon as we're done with this question, a survey is going to pop up and we'd love for you to take it. One more. Can someone who has committed suicide by gunshot with a gun near them not have GSR?
Another great question. And the quick answer to that is, it is possible. There are different amounts of particulate that are distributed when a firearm is discharged. If it happens to be a firearm that doesn't have a lot of openings, if it's very gas tight, it doesn't have a lot of openings for particulate to escape, then it is possible for you to discharge a firearm and have very few or no particles on you. On top of that, if someone has committed suicide, there's oftentimes biological material that is on his or her hands or clothing that could mask any potential residue. The environmental factors play a role too. Is it outside? Did it rain? Is it inside with airflow? There's lots of different circumstances in which an individual could commit suicide and not have gunshot residue on them. The probability, it's hard to say what the probability of that happening is, but it is a possibility.
Okay, I apologize for everyone whose questions we didn't get to. I'm going to hand them over to Allison, and if she's nice enough, she'll email you back with the answers.
You bet I will.
Yeah. So thank you for joining us. Thank you for everything that you do to keep our country safe. We appreciate it here at RJ Lee Group. Stay healthy out there.
Thank you all. Thank you for your time.